I just wanted to start out by explaining a little bit about the book, some of the topics, and then we're actually going to have some of the authors come up and present the topics that they wrote about to explain a little bit more. So the authors are myself, Ross, who you heard from looking to get some help over at Flickr, Julien Lecomte from Yahoo Search, is that right? Yeah. From Yahoo Search is also the creator of YUI Compressor. Stephen Levithan, who is not here, unfortunately he's not local, but he knows more about strings and regular expressions in JavaScript than anybody that I've ever met or talked to. So that's what he ended up writing about. We have Stoyan Stefanov, also from Yahoo Search. And you may also know him from YSlow and a bunch of other performance-related stuff he's done here at Yahoo. And Matt Sweeney, who's an architect here on YUI. And so the chapters, there's just 10, and we try to really take you from the beginning of writing your JavaScript, getting it onto the page, optimizing it for runtime, getting it out into the wild. And so these are the topics. I'm not going to do the annoying thing and read all the bullet points off of it. But some of the chapters written by me, various chapters written by other people, and we're just going to focus on a few of those tonight. So we'll start off with Stoyan, who's going to talk about DOM scripting. And then I'll have myself. I'll talk about responsive interfaces, how to keep the browser nice and quick. And then Ross is going to talk a little bit about AJAX. And we'll have Julien talking about build and deployment. And then we'll have Matt talking about tools. And I did feel a little bit bad that Stephen couldn't be here, so I wanted to give him a little shout out. This is his blog. It's really great. Lots of interesting stuff on there. And he's also the co-author of the Regular Expressions Cookbook from O'Reilly. So he really knows his stuff really, really well. His latest blog post is about some of the mistakes that were made in the JavaScript regular expression API. Really interesting stuff. And just before we get started with Stoyan, I just wanted to answer the question that I've been asked a lot since this book first came out, is does this really matter? Like JavaScript engines are getting so much faster, so should we even care about performance? And the answer is yes, because compiling JavaScript only solves some of the problems that we deal with. Because if you think of it now, 5 years ago, we had a bunch of applications on our desktop that we thought were kind of slow. And then all of a sudden, memory gets cheaper and cheaper, and processing power gets cheaper and cheaper, and we expect everything to get fast. But I don't know about you, but I still use applications every day on like my dual core processor that are really, really slow. So there are still things that you can do, even with all of these latest JavaScript engine optimizations, to make your code slow. So there's always going to be bottlenecks. And the book tries to cover not just things that might eventually go away in the future if JavaScript engines catch up, but also the things that you need to keep an eye on, the things that you may just make mistakes in as you're trying to write a ton of JavaScript. So with that, we're going to bring up Stoyan. We'll have a brief switch of computers, so please bear with us.
Hello, everyone. Great to see you all. Thanks for coming. I'm Stoyan. I had the honor of contributing one chapter to Nicholas's great new book. It's about the DOM. So tonight, I want to talk about the topic is the DOM is slow, right? So going to go through how slow exactly we're talking about, why is it that it's slow, what's slowing down, and what we can do about it. So let's start first with one sort of a bad example. So what's bad here is we're accessing a DOM element and updating its inner HTML. So we're touching it once to read the value, once to update the value, and we do that in a sort of a big loop, right, just to see what happens. So we have here 2 accesses to the DOM per iteration times the number of iterations. So the better way is to just use a local variable, right, and do all the updates to that local variable. And once you're ready, update the DOM So that gives you you're touching the DOM only 2 times, right? Looks really simple. And so let's see how bad could that be. So just to give you an idea of all the graphs in the chapter are something like this. I tested across a bunch of browsers, and I'm not comparing them in any way, and not worried about milliseconds and so on, and which one is slower, which one is faster. That doesn't really matter because your application will run there. There's nothing you can do about it, right? So my idea was, given 2 ways to do the same thing, which one would you prefer? Like, which one would be faster than the other one? So in this case, if you do the bad way, if you touch the DOM so many times, it's going to be 155 times slower in IE. So that's not percentages. That's really slow and bad and horrible. So it's basically then what I wanted to check is it consistent across all the browsers, right? And it turns out it's, to one degree or another, that's the story across all the browsers. So it's slow everywhere. So even if you look at the smallest bar up there, it's still 20 times slower, right? It's ridiculously slow. So why is that? Why slow? I heard that sort of a comparison from John Hrvatin from Microsoft, that you have something like a bridge, right? When you're in your ECMAScript land, right, you do your loops and functions, objects, and all that. You're staying within the ECMAScript. But then when you have to access an element in the DOM tree, you have to cross a bridge. And be careful, there's a special effects here, so you don't want to miss that on the slide. So, and this is a toll bridge, so every time you cross that bridge, then you have to pay a certain penalty every time. So the more you cross it, then the slower you get. So these are the special effects. And going to DOM land, paying the toll, and then coming back to your JavaScript manipulation. So this was only for accessing the DOM, right? So what about when you update stuff, right? Because you change some things here and there, add new elements, and so on. So in order to kind of understand that, let's take a look at what the browser does. So that first it gets a soup of HTML tags, right, and tries to make sense of it all and create some DOM tree. So this is pretty well understood, right? We can see the DOM tree in Firebug and so on. So then it gets a bunch of style information, right? User agent style sheets, user styles, document page styles, inline styles, and again makes some sense of it, removes the syntax errors and all that, and creates some sort of a structure. And then it proceeds to building this rendering tree. So you can think of it as something like the DOM tree, but not every element in the DOM tree corresponds to an element in the rendering tree. So the rendering tree is just a bunch of boxes, right? And those boxes will be painted on the screen eventually. So for things like the head element, right, invisible stuff, you don't have a corresponding element in the rendering tree. But for some other stuff like text, you might have several lines of text and several of those boxes. And then once the browser calculates all the layout, then it proceeds to painting it on the screen. So what happens when you update the DOM or any of the styles, right, and you change something on the page, it has to go through this process and repaint portion of the page or the whole page. Also, the user might affect that with resizing the window, changing font size, and causing those repaints. So some of those repaints will actually be changing. Some of the changes you do will affect the geometry of the page, width, height, padding, borders. In this case, the browser has to recalculate part of that tree, some of those boxes, and get all the dimensions. So this is what we call reflow. All right, so not all the changes require reflow, only some of them. And because it's kind of an involved process and could be expensive, so the browsers are smart enough to optimize this sort of, avoid doing all this work of constantly painting and reflowing. So they actually optimize when you change several styles, right? The browser will not apply them right away, but will create a queue of all the things you want to change. And then after you reach a certain number of items in the queue, or after a certain timeout, it will just flush the queue and do several changes at the same time. But you can actually bypass this optimization and slow things down by requesting computed styles, offset, basically requesting any layout information. In this case, because the browser is kind of a single-threaded thing, right? So then it has to flush the queue in order to give you the most accurate value, because when you change something, you expect when you request the computed style to be updated. So the DOM tree and all that was pretty well understood, but basically we had no idea what's going on with when does the reflows happen, repaints, and so on until recently. So there's two excellent tools. One is Dynatrace Ajax Edition for IE, and the other one is Speed Tracer for Chrome from Google. So here in Dynatrace, in addition to the normal waterfall, right, the network activity here, then you also get when rendering activities are happening, when some JavaScript is executed, CPU utilization, kinds of very, very detailed information, and so detailed that it's kind of hard to look at, right, because it's too much of it. So in this case, there's some JavaScript event and something is being redrawn. So you can actually zoom into that, and this is actually, you can zoom in that part that was changed, right? And you can see the blue thing is your JavaScript function being executed, and then you can actually click on that and see the exact function that was called. And then you see when that the browser spent some time calculating the flow, means reflowing, calculating dimensions and all that, and then painting. Even in this simple example, you can see how long is the painting line, much longer than whatever you could do in JavaScript, right? So it's good now that all the browsers try to speed up, and they're competing in JavaScript performance, in the ECMAScript sort of stuff. But it's good for them to also start optimizing this stuff. And IE9, they've announced that they're using now the GPU, the graphical processing unit, when it's available, so that it can help with that styling and reflowing and making it faster. So this is Google Speed Tracer. Again, you have a list of events that happened. You can see, some click happened, then there was some style calculation, and eventually some painting. And then you can expand also and see more detailed information about, when was style calculated, when was the layout calculated. So in Chrome, you can have the difference between just changing a style, like a background color, something that doesn't affect the geometry at all, versus changing the layout. So you can see here what I was mentioning, that you can actually flush the queue and make the browser perform everything right away. So the bottom is the good example, right? You change a bunch of colors at the same time, and then you ask for computed information, for the computed styles, like the layout information. But if you do one change, one request for computed style, another change, you're actually flushing the queue every time. And you can see in Speed Trace, you have, okay, style calculation, flow, style, flow, where here it queued all the three. And then when you requested the computed style, it calculated the styles and the geometry only once. So what to do about it? I'm not going to go into many details. It's all in the book, right? So, I want to give you 10 commandments, right? Don't touch the DOM. Yeah, it's true, not really helpful, right? So the next time when the client says, says, okay, I want to change that color to red, when there's an error, and you say, no, I'm not touching the DOM. Forget about it. So one thing to do is to cache the DOM references in local variables. So when you cross that bridge, you pay your toll and store that in a local variable and work with that. And again, in the different browsers, it's different. It can be anywhere from 2 times faster than to 200 times faster. Selectors API, use Selectors API when they're available, or make sure your library is using the Selectors API. Just update the JavaScript library, because that's always going to be faster than anything you can do to find the nodes that you want to work with. Caching the length for collections, right? Collections, when you do document get elements by tag name. So this is an HTML collection, right? So when you loop through that, if you check if I is less than the length of the collection, then because it's a live collection, it has to to check the document every time. So when you cache it before the loop, it only executes once, and it's, again, 200, 300 times, depending on the browser. Will be faster. When you have a bunch of DOM changes, take the DOM element off the tree, perform your changes offline, and then put it back in the tree. As opposed to, when you have let's say a table with 100 rows, you don't want to be adding one row, another row to the live document. You just want to create everything offline in a document fragment or a clone if you're changing an existing node, and then put it back in the tree. Style changes, again, you might be causing more reflows, and so when you have to update a bunch of styles, the cleanest thing is just to update the class name. But sometimes, you cannot do that. You don't know the style in advance, right? So if it's a drag drop or something like this, so you can change the CSS text property and pass it a string of all the stuff that you want to change. What I talked about, asking for layered information, offsets, scroll amounts, and any computed style. In the previous example, if you saw that you're actually changing something and requesting some totally unrelated computed style, but the browser still have to flush that queue. Minimizing reflow areas. So when you're about to change something, think about how much this change will affect the rest of the page, right? Will it's going to reflow the whole page or just a part of it? For example, if you have at the top, it's kind of popular now with sort of like Firefox that gives you a message. So people do that sometimes. So that has to reflow, animate and reflow the whole page, right? So it might be a good idea to position that absolutely, animate, and then move the rest of the document. Using event delegation always helps. If you haven't looked at YUI3 delegate methods, it's really good. It gives you, you can pass it a selector for the wrapper that you want to listen to, and then you pass another selector only for the elements that you're interested in. So it's really good stuff. And you can see I've struggled to make them 10. Right? So the last one is, again, the DOM is slow, so don't think about it. Every time you type document dot, then a bell should ring and say, oh, that's going to be, I have to pay for that. Right? Thank you very much.
So one of the things that I find interesting about JavaScript is how it affects the user interface of the web page, just in general. Especially now that we put so much JavaScript on the page, I think that we don't really recognize just what sort of impact that can have on the user. And so I wanted to talk a little bit about how to keep the user interface really snappy and responsive. And to do that, we have to dig into the browser a little bit. And I'll warn you ahead of time, some of this is an oversimplification. If you want to talk actual details, you can catch up with me afterwards. But I just wanted to get these simple examples out there to kind of get you guys thinking about what's really going on underneath the covers. So there's this thing that is sometimes referred to as the UI thread in browsers, or the UI process. And it basically has two jobs. So the first is to draw UI updates, right? Whenever anything changes on the page or when the page is first loaded, the UI thread goes and draws this stuff. So the stuff that Stoyan is talking about with reflow, repaint, these are all jobs for the UI thread to do. So interestingly, the UI thread is also responsible for executing JavaScript. So it has two jobs instead of just one, even though it doesn't seem immediately apparent why that would be. So the thing that you need to watch out for is only one of these jobs can actually happen at a time. Right? You can't update a UI while you're running JavaScript or vice versa. It just doesn't work. And I'll explain a little bit about why that is. If there's a job that's already executing on the UI thread and another one comes along, then that one ends up getting queued someplace so that it can be executed in the order in which it was received. So kind of like when you call and you're put on hold and it says, you'll be dealt with. Nobody's even chuckling at that? Okay. So you have some basic code, right, that's just like to have a button do something. So this is it, my really big button, which actually does nothing. Right, but there's a few things that are going on here. Right? There's a couple of UI updates that are going on. First, when I hit the button down, and the button actually goes down, and then when I release it, it comes back up. So it's two draw operations. And so this is what actually is happening when you click on the button. So there's a UI change job that says, hey, draw this button in the down state first. And then after that, there's a JavaScript execution job for the on-click handler for that button. And then after that, there's, okay, draw the button now in the up state. So these all happen behind the scenes as soon as you click on the button. And so if we think about this logically, we have the button just sitting out there, and then there's a UI thread. And we'll assume up here that this is sort of a timeline of the UI thread so you can tell what's going on. So before the click, there's nothing going on. The page is completely loaded. There's no JavaScript being executed. It's just waiting to do something. So you click, and immediately these three jobs get added into the UI queue. Clarification, yes.
So it's actually JavaScript thread that's redrawing elements, the hover effect is not being caused by the browser. It's part of the JavaScript takes over.
So is the question, sorry, can you say that again? So let me see if I can summarize this correctly. So the question was, if there's one JavaScript process, is the browser making that busy so JavaScript can't do stuff? No.
So this week could be because there's an on-click event, but the fact that it's being redrawn is actually CSS, not being told by JavaScript.
So yes, the fact that it's being redrawn is by CSS or just by default browser rendering behavior. It doesn't have to do with JavaScript. Yes, it's still one thread, one process. Cool. Any other questions about that? Okay, so there are three jobs that end up getting generated when you click on the button. So I've represented them visually here as the button being in the depressed state, as some of us get from time to time, and then the on-click handler, and then the raised state. And so these go into the queue, and then they start getting executed. So first, says, well, let's draw the down state. Okay, and then once that's done, then we go on to the on-click handler and execute that. And then we draw the up state. And then after that, we go back to doing nothing and just waiting for more jobs to come in. And if you think about it, this happens mostly when you're interacting with the page. You click on something, there's some sort of visual change. Maybe you have some JavaScript action attached to it. Question? So the question was, what happens if there are multiple clicks or clicks in different places? Do those all get queued up? Yes. So whenever there are other jobs that are being executed by the UI thread, any other ones that come in end up getting queued up and added into the UI queue. No, so it won't stop what it's doing in order to add stuff to the queue. It's magic like that. So it shouldn't get in the way. It shouldn't get in the way of anything else. But you can actually see if you're running a very long-running JavaScript, and then you start interacting with the page, you can actually get it to be non-responsive because it's trying to queue and trying to do what you were telling it to do before, and it really doesn't like that. Yep. So if you do a set timeout, where will that be in the queue? Okay. So skipping a little bit ahead, but I'll answer it. So what happens when you do a set timeout, what you're actually saying is after a certain amount of time, add this to the queue. Right? It's not after a certain amount of time, execute this. So if you say set timeout, some function, 500, what you're actually saying is after 500 milliseconds, add this job to the queue. And that can actually be really useful, and I'll show you that a little bit later. So UI thread. We just did 3 things in a row. Important thing is that no UI updates while JavaScript is executing. So even though in your JavaScript you're manipulating the DOM, maybe you're changing classes, moving stuff around, none of that happens while the JavaScript is executing. It's basically batched to be done afterwards. And it kind of makes sense if you stop and think about it, is because when the JavaScript causes a UI update, like this is just a really stupid example of adding a div here, you want to make sure that the next UI update is doing everything it's supposed to do. And you can only be assured of that if you wait until the JavaScript finishes executing. So, hey, that's what I just said. UI updates must use the latest info available. And I actually have this other example to show you. So here's another button. We're trying to make it a little bit clearer. This one, the JavaScript handler takes a couple of seconds to execute. And so you can see actually this pause happen when I click, that it stays in the depressed state for a little bit longer while it's executing the JavaScript, and then it comes back up. And so again, the reason for that is think, maybe I changed the color of the button, maybe I changed the position of the button, maybe I changed something above the button that forced it to draw down, to move down in the page, and then we have to be drawn down later. So the browser doesn't want to do a UI update until it has all of the relevant information to make sure that it's drawing correctly. And so the longer that your JavaScript runs, the more unresponsive your UI becomes. And I used to have this great example of this. How many people remember bubble sort from computer science? Oh, good. A bunch of us. And do we all remember that's like the first one that they taught you? And then after that, they said you should never do that because it's really, really slow and horrible. So I had this great example using a bubble sort that in previous browser versions, it would take like forever to execute. And this one I actually have to kind of race because it's Firefox 3.6 and it's kind of fast. But basically what I have here is a drag and drop example. So all of these are draggable. So you can move around. And as soon as I click start here, I'm going to start sorting an array of 5,000 items with bubble sort. And then try to move something. And you'll see that the stuff isn't moving. Oh, and then that's done. It's really anticlimactic when it's done in 5 seconds. So we'll just keep doing it until people are impressed. So can't move it. There we go. Thank you. And so the browser actually tries to protect you from JavaScript that goes awry with this thing called the runaway script timer. And I always think of it as funny, like a little kid running away. And the first time I saw runaway script timer, I really couldn't quite wrap my head around what it meant. Marcel, is that a question?
Yeah. What happens if you remove the button when it's pressed? Remove from the DOM.
What happens when you remove the button when it's pressed? So on click, you remove the button?
Yeah, on click, yeah.
So basically, so there's still a UI update that comes after that, but that UI update is to erase the button. Go ahead.
What if you call an AJAX web service, let's say? You click something and you call a web service, and a second, like, you're waiting for the answer. It's like 5 seconds, let's say.
Okay, so the question was, what happens if when you click on that, you make an AJAX request, that's asynchronous, then what happens? So, trying to think of the best way to explain this. Being asynchronous basically means don't block stuff. At least that's my very, very simple explanation. Asynchronous, don't block other stuff from happening. So as soon as you fire off that request, that JavaScript job is finished. Right? It doesn't have to do anything else. When the response comes back, then a new JavaScript job is created and inserted into the queue, and then that gets executed at the next available point in time. So you're not actually blocking anything. It's a little bit like set timeout, is that JavaScript job isn't getting added until a later point in time. Yep.
I have a question regarding the batch update. Previous presentation, whenever you want to do UI updates, you have to do it in a batch. But I think from your presentation, I'm assuming even though you do update multiple times in JavaScript, the browser is still going to do as a batch. So is that, I mean, when I write code, do I have to ensure I do it in batch, or do I say browser already takes care of it? So,
Okay, so the question was, Stoyan just was up here and was saying, hey, make sure that you're batching all of your UI updates together. And then I said, hey, the browser is batching all of those UI updates together. Like, who's right? And the answer is always me. But in this case, we're both right. So the browser tries to do what's logical. And it tries to batch up the updates in whatever is the most logical way. What you can end up doing sometimes is creating too many of those steps. So if you're going through and you're changing, as Stoyan was showing, multiple styles, then you're creating a bunch of steps to be batched up instead of just one. And then there are some other things that you can do that actually trigger the browser to stop and do a calculation of what the UI updates will be, even before the JavaScript ends up finished. And that can slow things down as well. And Stoyan explained that really well in the book. But good question. I'm glad people are laughing now because that would have made this really painful. So the runaway script timer, its job is to prevent you from doing something stupid. It's to prevent you from writing code that takes so long to execute that the browser stops responding and that you could potentially end up with memory issues and whatnot. So that's the runaway script timer. And apparently I said a bunch of this stuff already. So there are two types of limits. One is execution time. So that's the total amount of time that the UI thread has spent processing a single JavaScript job. And then the other one is the total number of statements that have been executed in JavaScript. And so these are both affected by the new JavaScript engines that come out, because you can execute more within the same amount of time, and you can also execute more statements within a certain amount of time. So the current, oh yeah, they always pop up as scary dialogue to the user. And Opera is the interesting one because it doesn't have a runaway timer. It does some smart things to protect you from bringing down the browser. But here's the scary dialogue from Internet Explorer. Has people seen this before? Yes, very scary. Firefox is also scary. Safari, a little bit scary. Chrome, really kind of upsetting, I think is the word for that. So Chrome actually does something interesting. It doesn't have a separate runaway script timer, but it ties into the general crash protection mechanism, and that makes unhappy folders left and right. And so the limits that we're actually looking at here is Internet Explorer has a limit of 5 million statements. If you feel like hacking the registry, you can actually change that, but I wouldn't recommend it. Firefox, last time I checked, was about 10 seconds, and I'll admit that I did not check that in Firefox 3.6 before I came up here. Safari was 5 seconds. Chrome, it was really unsure. I could get it to crash if I really tried hard, but hopefully that doesn't happen normally. And then Opera, of course, none. And so how long is too long? It's a really interesting question that I will answer in just a second. Yep. So the question was, is the time limit based on a single part, a single job, or the entire queue? It's based on a single job. So you could have a bunch of JavaScript jobs that are queued up, and they don't affect each other. So one can take 1 second, one can take 2 seconds, so on. Okay, so how long is too long? Jacob Nielsen, who's this usability guy, I don't know if you guys have heard of him or not. He wrote this in his book that actually about 0.1 seconds or 100 milliseconds is about the limit for having the user feel that the system is reacting instantaneously, meaning that no special feedback is necessary except to display the result. So in layman's terms, that means if it takes longer than 100 milliseconds for the UI to do something, the user thinks that something might be broken. And you might say, well, that's a really short amount of time. Are you sure that that's it? And so Ben and Dion from Ajaxion did this really cool demo last year at Velocity, and I thought I would steal that and show it to you because it was such a good example. And so here are a bunch of buttons that have a bunch of delays associated with them as to when, as to how long the JavaScript on click will actually execute. And so you can see as you go down, so no delay, pretty cool. 50 milliseconds, don't notice anything. 100 milliseconds, don't really notice anything. But then I think it starts becoming a little bit more obvious. By the time you get to 500 milliseconds, you can really kind of tell that something is going on. And so keeping these in mind can help you determine how long you should let your JavaScript run before giving it a break. So yes, JavaScript should not execute for longer than 100 milliseconds to ensure responsive UI. And what we're really talking about here is perceived performance of the UI. You don't want things to be pausing and jagged when they're trying to move around. My recommendation is, though, to keep it under 50 milliseconds at a time, because why even try to get close to that? Just give stuff a break, allow the browser some time to catch up. And so if you remember my drag and drop demo from earlier, using bubble sort, where I couldn't drag this stuff, I was basically doing that with regular bubble sort. So we have a loop inside of a loop, and that's a big pain. And basically, the process looks like this. Right? So you have an array, and you have some items, and you basically iterate over the array and process each one in some way. And so you could take this and turn it into a sort. You could take it and turn it into some other sort of processing mechanism. But basically, what you can do is use timers and set timeout to help break up the jobs. And so JavaScript timers are really cool. Everybody at some point in time has used set timeout, I'm sure. But basically, it schedules a new JavaScript execution job for some time in the future. So when that delay is up, the job is added into the queue, but it still has to wait its turn before it's going to get executed. And I just really want to point out that this does not guarantee that your code is going to get executed after a certain amount of time at all. It just guarantees that it gets added into the queue so that it will get executed eventually. I think some people still mistakenly believe that set timeout means execute this in 500 milliseconds or execute this in 1 second, and that's not the case. And so if you have a lot of complex processing that's going on, you can use these timers to your advantage to split up the functionality into smaller chunks. And in the case of like a bubble sort, what you're basically saying is I'm going to sort a little bit now, later on I'm going to sort a little bit more. And so this function is a little bit longer, but it basically does the same thing as the previous one. It does it using timers. And so I'm not going to get too much into the details of what the code is doing. I'm just going to give you a brief overview. It starts the job and marks what time it started. And then periodically it's going to check to see how much time has elapsed. And so if more than 50 milliseconds has elapsed, then it's going to stop, set a timeout, and then call the same function again to finish it. And so in this way, you're getting the most out of your JavaScript execution job. Because if you were to set a timeout for each item, it actually takes much longer. This way, you're at least getting as much done as you possibly can in a reasonable amount of time, and then delaying and doing a little bit more. And so if I apply this to my bubble sort example here, which has Firebug open and closed. So this has the same thing. I have a bunch of stuff that I can drag and drop around. And as soon as I hit start, it's going to start sorting. But because I'm using timers to do that, it actually frees up the UI to continue to do UI updates as I'm interacting with it. And the thing that you'll notice is that it's taking a little bit longer to complete. Oh, there's a round of applause. Hey, thank you. So it took a little bit longer to do that because you split it up. Right? But the goal was really to make sure that the UI wasn't frozen. And so that goal was achieved. And so when you're working on your web applications, you really have to stop and think, how much of this has to get done right now, or how much of it has to get done eventually? And if some of it has to get done eventually, then you can actually push it off until later. using a technique like this. And so there's this cool thing coming up called web workers. You guys heard about this? Yes. HTML5, yeah! Except they actually split it out, so it's a separate spec now. But nonetheless, it's still really cool. So the idea behind web workers, yeah, this is actually a screenshot of the spec for effect. And it has no useful information on it whatsoever. But it's up there if you want to read it. And I actually forget what my next slide is. So let me look at that first. Oh, my bullets are broken. What a shame. So web workers are a way to do asynchronous JavaScript execution. And basically what we're talking about is do the JavaScript execution off of the UI thread. So don't interfere with any of the UI updates. Don't interfere with any of the other JavaScript that might affect the UI. Just go do it someplace else. And it's completely data-driven. What that means is you can't access the DOM from within a web worker. And you can't access other parts that are related to the DOM. You can't access window. You can't access, actually can access location. Little trick thrown in there. And so when you pass data into a web worker, the data is serialized, and it comes out the other side as an execution job on a separate thread. And that all gets run just in one big batch, but it's not interfering with the UI. It's not interfering with other JavaScript. They said no access to the DOM, no access to the BOM. The completely separate execution environment lets you do pretty much whatever you want without worrying that it's going to affect the user experience. Unfortunately, I didn't have enough time to redo my bubble sort example with the web workers, but if I had, you would have seen it execute just as quickly as the first example, but without freezing the UI. And there's a lot of kind of intricacies to using web workers. They're not quite fully baked yet, but they're still fun to play around with, and they're definitely something that's going to be important in the future. So this is how basic web workers are set up. You create a new worker object, and you pass in a JavaScript file that has code to be executed within that worker. And then you post data into the worker by using post message, which is similar to the cross-iframe communication. And then when a message arrives back from the worker, so the worker can say, hey, I'm done, and I'm going to send a message back to you. There's an on-message event handler that you can assign to. And so this example, the second part here, is actually inside code.js. And what I've said is when this worker receives a message, just take the data that was passed in and pass it right back. And so on message for the worker, I'm receiving the string Nicholas in the data property on the event object. And then I'm just posting it back to the window using post message with hello prepended to it, and then alerting that out. Not very exciting in this case, but just so you could have a simple example, you can pass in any type of serializable data and do whatever you want with it inside the worker. And so web worker support right now, kind of limited. There's also some inconsistencies across browsers, but still a lot of fun to play with. So in summary, the UI thread is used for both JavaScript execution and UI updates. UI cannot be updated while JavaScript is executing and vice versa. Try to keep your JavaScript execution time to 50 milliseconds or less. And you can use timers or web workers to offload some of that until later if you're trying to do too much. And so that's it for me. That's all my contact information if you'd like to talk afterwards. That's it.
All right. So hi, I'm Ross Arms. I work at Flickr. I did the chapter in the book on AJAX. And instead of giving you guys a whole overview on AJAX performance optimizations, I'm going to focus on one really small bit, which I think is actually the most interesting part of the chapter, which is multi-part XHR. So how did multi-part XHR come about? Well, a few months ago, Dig came out with a really interesting blog post. Anyone from Dig here tonight? Oh, okay. Super interesting blog post on a way they're using XHR to optimize their pages. They have a problem which is really similar to a problem we have at Flickr. So they have really long pages with tons of small images. And the thing is that these little images you see, they're all buddy icons. So they're totally unique to each user. We can't sprite them. We can't really do anything in order to get them to be faster on the page. They're just, in this case, hundreds and hundreds of images. So what their solution to this problem was is to take all these images, and in fact, any sort of resource at all, HTML, CSS, JavaScript, on the server side, feed it into PHP or a language, turn it into a string, and then send it back to the browser in one request. So instead of having 500 requests for 500 images, you have a single one. Obviously, this speeds it up hugely. It's an unbelievable performance improvement. So here's what it looks like. In the server, you're going to sort of request your list of resources. This could be CSS. This could be JavaScript. In this case, it would just be a long list of buddy icons. You know, image1.jpg, image2. The server will go in and read all those files, convert them into some sort of string. In the case of images, it uses a base64 encoding. In the case of JavaScript and CSS, it's just using plain text. Rolls all those strings together with some sort of delimiter. In this case, we're using some sort of MIME boundary, which works just fine. And then we're sending this to the client side. So what the client side does is it gets one massive string. It then does what the client side does pretty well, which is just split on string, and gets back each of these resources. For each different one, in this case, image JPEG, it fires off just a listener. So we have a listener for JPEG, a listener for GIF, a listener for HTML, and then does something with the payload it gets. So here's sort of a diagram. So let's say on the server side, we're requesting 2 JPEGs, a GIF, HTML, CSS, and JavaScript. So we request this. The PHP goes through, reads all these. In the case of the image, it's going to convert it into a base64 string. And then we're going to send it all as one string back to the client side. The client side is going to take this one string, split it, and then do something with each resource. So for the, say, JPEG stuff, it's going to insert it into an image tag using base64 data URI. For the JavaScript, it's going to execute it. For the CSS, it's going to put it into a style. For the HTML, it's going to put it on the page wherever you like. So what are the benefits of this? Obviously, the huge benefit is to HTTP requests. Instead of having 500, 1,000, whatever, we just now have one. And this is true for any number of any type of resource. So instead of just concatenating your CSS together and your JavaScript together, you can concatenate both of them together into one file. It gives you the benefits of spreading images without actually knowing ahead of time which images you need. And in terms of the Dig user page and the Flickr photo page, this is a huge benefit because we have absolutely no idea ahead of time what images we need. It allows you to pull in all the HTML, all the CSS, all the JavaScript for a module on a page in one go. So let's say when a user clicks a button, you're going to load some modal dialog. You can bring in all the pieces you need for that in one request. Yeah, question? I'll get into that, but basically it's just a random string, whatever you choose to use, yeah. The question was, how do you delimit the images? And we just use a string. Anything works. So performance numbers. So the first time I ran this, I was completely shocked how much faster it was. I figure, okay, the images are really small. The HTTP request doesn't really matter that much. But in a normal browser, I think this was Firefox, we saw a 10-time improvement. So for loading 100 images, it took about 1.5 milliseconds per image. That's pretty ridiculous. So we saw it under a second for 500 images versus 11.5 seconds. So that's the difference between a usable page and one where the user will go somewhere else. For the mobile side, we did a test on the iPhone 3G and the Edge. And it's a difference of 4 seconds versus 49 seconds. And in the case of Edge, 30 versus, 124 seconds. I mean, no user is going to wait 124 seconds. So as I mentioned, Dig were the guys, the first ones to talk about this. They have an implementation out there. You can go look at it right now. It's super beta, a little buggy. They have this weird adherence to RFC 2046, which means they're using MIME boundaries as their delimiters, which is just a long string, which makes it sort of a little more structure, less payload. And they only pass one header per payload, and this header has to be the MIME type. So this means you can pass anything you want, any type of image, any type of CSS, but you have to have the header with it. And it means you have no way of pulling apart these images on the client side. So if I pass 10 images, the only thing I know is that they're an image. I don't know where in the page I've got to plug it into. So order is the only way you have of identifying which resource is which. So we've been playing around with it a little bit. We have a slightly different implementation. It's based off of Digs. It's also super beta. It really just throws away this RFC 2046 structure and uses control character as delimiters. Control characters won't appear in any sort of base64 encoded image. They hopefully won't be in your JavaScript, otherwise it's not going to work. But they're really small. They're just a character. So instead of a long 20-character string, we just have a single character delimiter. We also allow multiple headers. So you can have the MIME type, you can have an ID, you can have really any sort of key value pairs that you need to pass with this data in order to know where to put it in your page. It also fixes a few really minor bugs in the implementation. Nothing major, but just a few edge cases. So, small problems with this approach. It sounds too good to be true, and in a lot of ways it really is. The small problems you're going to run into, the first one is Safari's tiny call stack limit. This is implemented as a recursive function, and because of that, Safari 2 will halt after 90 recursive executions. That's the length of the call stack. In Safari 3, which most people are on these days, that's up to 490. So you're really fine. 490 resources is a lot. That really gets you through most pages. The second small problem is that it requires JS. These days, I guess every page requires JS, but at Flickr, we really try to have a workable page without JS. So you have to have some weird fallbacks in this case. We went through one case where we were having a cookie set to say whether there's JS enabled, so we knew on the server side whether we could use this or not. But depending on how your framework operates, this may not be a problem. So the big problems, these are the things that will actually stop you from using this. Caching, it does not do any sort of caching. So you get this massive string back from the server, you have all these images, and you have no way of fitting these images back into the cache so that next time the page loads, you have them there. This is sort of a big deal. Ideally, you would fetch all these images and then through some sort of API, feed them back into the cache, but that way doesn't exist. Yeah? The question is, are we doing a post request? I believe it doesn't matter. You can use post or get. It's possible. Yeah, I don't know. But you can use get or post for this. Doesn't really matter. Yeah, so cache is a big problem there. Images don't work in IE. So this isn't necessarily true. Let me get you in a second with the question. So the problem is that we're using base64 encoded images, and we're passing them into the actual DOM, into the page, as a data URI. This works fine in all browsers except for IE, of course. So there are workarounds for this. There's a thing called mHTML. There's a great post about this the other day I couldn't find in time for this presentation. And it may be a great workaround. It's basically a way of feeding base64 encoded images as a string into IE. Sorry? I don't know. Yeah. There's another possibility. Hedger was doing on some really interesting stuff with base64 images and email. It's some ancient RFC that actually still works in IE. So it's possible that this can work in IE, but for right now, we haven't found a really great, easy solution. Yeah, question.
What about the HTTP pipelining? Because this is basically a reinvention of that. Why aren't people pushing the pipeline to make it work?
So the question is, what about HTTP pipelining? Isn't this just basically redoing it? In a way, yeah. It's actually turns out to be a little faster than pipelining. So pipelining is just when you have multiple requests at the same time. And this is just one big request. In actuality, I'm not sure there's much difference, but I found better performance with this, actually. Good question. So how are we planning on using this awesome thing that probably won't work in half of our users? So we're not going to use it on our main site. We just don't have a way yet around IE. But if you have a site that just basically caters to high-end browsers, Firefox, WebKit, say like the gentleman in the front row that has the iPad, that's a perfect example of where this might be useful. We're going to try to use it on our mobile site. We have a version of the site that is just basically optimized for smartphones, for iPads, Android, WebOS, iPhone devices. And we have another one we can fall back to, so you don't have to worry about the supporting devices. We can't really handle the MXHR. So what we're actually doing is detecting JS. If JS is there, then we're going to not load the page with any images, have one big request, insert them all on the page, and save just a ton of time on photo pages with a lot of comments. So the big reason this works so well in the mobile environment is that caching is not a big deal. So if you've ever been cruising around on your iPhone or the iPad, you'll notice it basically does no caching whatsoever. You go to a page, you go to another one and hit back, and it reloads the whole page over again. So really, we're not losing anything by not having caching there. They also can handle all aspects of the MXHR. They can do XHR streaming. They can get the stream, get the data in midstream and slice it up as it's coming in. So everything works. But of course, this is part of our mobile site, and we're actually hiring for that right now. So if this sounds interesting to you, if you want to be the guy to implement MXHR for Flickr, come work in our ridiculous work environment. All the info, all the contact stuff, flickr.com jobs. We've got a ton of stuff on there. So that's it. You can find the code here. If you have any questions, ask them now. Feel free to email me. I'm happy to answer them. Yeah. The question is, do we cache to local storage? So there's a really interesting idea, and it's one we actually thought about. So what you have at local storage is essentially a way of recreating browser cache, because all you're getting is strings anyway, and you can throw strings into it. It's totally possible. It's a little crazy, but I mean, there's no reason it wouldn't work. You could absolutely do that.
So I wrote this chapter. I'm going to try to cover it a little bit in this presentation. It's not the sexiest topic to talk about when it comes to performance, but I think it's one of the most neglected areas, which is why I decided to contribute this chapter to the book. So you can't talk about building applications without at least mentioning one of these tools. Make, obviously, which came to us from the Unix world. Make uses what's called a makefile, which is a text file with a special format. That text file specifies how to derive the target program from each of its dependencies. Apache Ant is another build tool which is implemented in Java. It uses XML to describe the build process. So this makes it available on many different platforms, and it makes the build descriptor file portable. So an Ant, so I'm going to talk very quickly about Ant because I have a few examples later that uses an Ant build file. So an Ant build file is composed of target elements. Each target contains tasks, and targets can list other tasks. Other targets as dependencies, and Ant comes with a lot of native tasks right out of the box. Two examples are copy, for example, to copy a set of files, and javac, for example, to compile a set of Java files. There are many other tools, of course. Ruby folks like to use rake, which uses a Ruby-style syntax to describe the build process, which also makes it platform independent. At the end of the day, just use whatever you're most familiar with, as long as it gets the job done. So first thing you can do in your build process is to combine JavaScript files. The goal is to reduce the number of HTTP components required to render the page. I think that's the rule number 1 in the Yahoo exceptional performance list. So let's see how you can do this using a makefile. So this is a very trivial example where I just concatenate two files, a.js and b.js, using the cat utility. That's really simple. Now, let's see a slightly more complicated example using Ant. So as you can see here, I declare a target. Its name is js.concatenate, inside of which I use the concat task. I specify the destination file, and then the files that I'm going to concatenate. So here, I use a file list and a file set. Using a combination of a file list and a file set allows me to handle dependencies, which means that I can put at the top of my concatenated file the things that the files at the bottom will require. So this seems a little scary, but it's actually really simple once you get the hang of it. Next thing you can do as part of your build process is to minify your JavaScript files. So JavaScript minification is the process by which a JavaScript file is stripped of everything that is not absolutely essential to its execution. JSMin is the first widely used JavaScript minification tool. Still very popular today. The YUI compressor is a tool that I contributed to the YUI project. The main feature of the YUI compressor over JSMin is that it obfuscates local variable names. So it yields slightly better compression ratio. You can actually see Nicolas or Nicolas' presentation on how to actually make better use of the YUI compressor. I think it's on the YUI Theater. And the latest tool, the new kid on the block, is Google's Closure Compiler, which is kind of where I wanted to take the YUI compressor a few years ago. They do a better job at actually analyzing the code and figuring out what is not useful at the end. It yields better, I mean, it yields higher savings than the other tools, but you have to be aware that it heavily obfuscates the target file, and that can make debugging a little tricky. So it's kind of a compromise. You know, you get smaller files, allowing for faster download, but maybe higher cost, trying to figure out what's wrong when something goes wrong. Using make, this is how you would invoke the YUI compressor. Very basic. On the left side is the target file, and on the right side, the requirement, and then the command line that runs the YUI compressor. And this is a slightly more complicated example using ant. Again, looks scary. It's actually really simple. I declare a property at the top. I actually stole this from the YUI builder thing on GitHub. So I declare a macro called YUIC. That macro takes 3 parameters, src, dst, and args, and then it just runs the YUI compressor. And then at the very end, I actually invoke that macro, specifying the source file as foo.js, the destination file as foo-min.js, and the arguments, variables, and charset stuff. As part of the build and deployment process, serving JavaScript files gzipped is probably one of the most important things you can do. So web browser usually send an accept encoding HTTP request header. This lets the web server know that what kinds of encodings it supports. This is primarily used to allow a document to be compressed, which enables faster downloads and therefore a better user experience. So possible values which are registered are gzip, compress, deflate, and identity. The web server then chooses from that list the most appropriate encoding method and notifies the web browser of its decision using the content encoding HTTP response header. So gzip is by far the most popular encoding. If you use Apache, Apache 1x uses mod gzip, and Apache 2x requires mod deflate. So all it takes for you to enable gzip encoding is to install those modules and configure them. There's a lot of documentation on the web on how to do this. Be aware that research that was done at Yahoo and at Google and other companies has shown that about 15% of our web traffic in the US is not compressed. The reason is that we just don't get the accept encoding HTTP request header. It's either missing or it's garbled, and it's related to proxies or to PC security software. So it's actually important to make sure that your code is as small as possible, even before gzipping, because of this. So here's the kind of savings you can get by using the YUI compressor and gzipping. So you go from 120K to 19K over the wire. The next thing is caching. So you want to cache your assets. Caching on the web is based on the expires HTTP response header. Below is an example on how to do this using Apache. So caching addresses repeating visitors. So web servers use the expires HTTP response header to let clients know how long a resource can be cached. So 1 year in the future is the best value you can use. You shouldn't use a value that's longer than 1 year. So mobile phones like the iPhone, for example, have cache size limitations. So be aware of this. In which case, it actually might be a good idea to split files. So you kind of have a compromise here where you have more HTTP requests, but you take advantage of cacheability. So it all depends on your application and the kind of usage it gets. You can also use the HTML5 offline application cache, which is enabled in Firefox 3.5, Safari 4, and iPhone OS, starting with 2.1. The next thing is if you use caching, you have to make sure that your users get the latest version of the content when you, let's say, fix a bug or introduce a new feature. So the best thing to do this is to rename your static assets. And I personally prefer to use a timestamp. And this is how you can do this using Ant. So you can automate the renaming of the timestamping of your static assets using your favorite build tool. Finally, also a huge, something that's really simple but will make a huge difference is to use a CDN. So what's a content, CDN stands for Content Delivery Network. So a CDN is a network of computers distributed geographically across the internet that's responsible for delivering content to end users. They achieve much better performance than you could do on your own by serving content from the location that's closest to the user, which decreases network latency. Also, if the node that's closer to the user fails, then another one will take over. It will be a little slower, but very reliable. So there are a lot of many third-party CDN providers. Also, some bigger companies maintain their own CDN. Popular JavaScript libraries like YUI are all available to access via CDN. So, for example, the YUI library is served directly from the Yahoo network via the yui.yahooapis.com domain. And there you go. That's how you can get in contact with me. And the next speaker is Matt. Matt is a rock star YUI architect.
I'm going to whip through this pretty quick. The book has more details. It's fairly straightforward. We're going to cover a couple of classes of performance tools. The first will be network analyzers. These are things that you can do to optimize the delivery of the assets to your page. Make sure that your servers are performing optimally, that you're combining all of your assets correctly, etc. Here is a handful of the tools that fall into this category that we'll be dipping into a little bit deeper. The second set of tools, profilers. These are tools that you can use to measure the runtime execution of the scripts during the life cycle of your page view, session, etc. Some crossover there between the previous set of tools. Okay, so the first one we have here, Why Slow, is pretty tried and true. Hopefully most of you guys have run this a few times. This was developed internally at Yahoo way back by Steve Souders and then refined by our man Stoyan over here. So this will give you kind of an overall score of how you're doing delivering the content to your page. It'll give you some kind of scorecard. Hopefully you're doing a little better than these guys. Won't point any fingers. But, break it out based on what are you doing, what should you be doing, give you some nice little tips and things here. Fairly straightforward. This is based on lots of research over the years that's boiled down to a handful of performance rules that hopefully you guys have all burned into your brains at this point. It gives you a nice little breakout here of what the total, how the weight of your page is distributed. You can see what an empty cache looks like versus a primed cache, sort of help you fine-tune some of your loading strategies. If you have 23 JavaScript files, you're probably have a lot of room for improvement there. It's a Firefox-specific tool. Yeah, that's about all I got to say on that one. Next up, page speed. This is a great tool that came out of Google. So this guy will, a lot of overlap with why slow, essentially kind of help you understand what's going on with the delivery of your assets and things. But one of the really cool features it has here is we'll run through and tell you which functions on this page haven't been called before the onload event fires. And so those are potential deferral candidates. So you might think about lazy loading those or bootstrapping those after the onload has fired. The idea there being that that's nothing you need to build up that initial view, and ideally that's maybe something that could be optional for the user for that particular view. It'll also tell you which, and here's the report, by the way, of what it might look like. It'll also tell you which functions were never called, which can be really valuable too. It could be that depending on the state of the page and what the user's doing, that sometimes the function will get called and sometimes it wouldn't. But it's nice to audit that kind of stuff every once in a while. Make sure that you're not just loading dead code into the page. Here's the kind of the activity view. I won't get too deep into the nitty-gritty here, but one of the interesting things that you can see is the red blocks indicate the time spent parsing your script, and the dark blue blocks indicate how long that script took to execute. So that can also give you some clues around what's going on. If you have really long parse steps, you might consider breaking that file up into smaller files. If you have really long execution phases, you may consider deferring some of that or seeing how you can not necessarily instantiate all of that code up front. Again, this is a Firefox via Firebug add-on. Yeah, like I said, a couple of the nice features there. Okay, so now we have Firebug's net panel or net tab, which gives you similar data. This one is a nice little waterfall diagram of kind of how these assets are being loaded, and it can give you some clues as to which assets might be blocking some of the other assets, potentially slowing down the page. You may want to consider asynchronously loading or bootstrapping some of those post-onload potentially. Again, just clues that you can use to help understand the performance of the delivery. Comes with Firefox. It indicates, so I don't know if you noticed here, there's a blue line that indicates when the DOM content load event fires, and then the red line indicates when the onload event fires. Sort of help to give you an idea of what's happening when, as far as the loading life cycle of your page. And additionally, it'll help you understand sort of what's actually happening with each step of the request. How much time was spent in the DNS, how much was sending, receiving, etc. Getfirebug.com, I'm sure you have that already. Moving right along into Web Inspector. Similar to Firebug, this one's for WebKit /Safari/Chrome. Similar data it provides here as far as the resource view. One interesting thing is they'll break out the time and the size, kind of keeping the views nice and clean there. But same basic data, different browser subset. Fiddler, and if you've been doing this stuff for a while, you've probably fired up Fiddler a couple times here and there. This is a cross-browser tool that basically can monitor all of your HTTP traffic and help you get a better handle on it, similar to the Net tab and the Resources panel. Web Inspector and Firebug, it'll give you kind of the waterfall diagram, sort of break out your assets by type. It'll let you get a quick bird's eye view into one, where the bulk of your assets are, and two, how those are performing over the wire. Yep. Dynatrace, this is a really cool new tool that's currently IE only, although they're saying Firefox is coming soon. This one is really a full spectrum end-to-end network analyzer and profiler. Gives you all kinds of great little views into what's actually happening here. You can see, for example, it'll break out the triggers, so which events were responsible for the bulk of the execution, etc. And it reports everything as all kind of the same part of the same summary. So it's really nice. You can see kind of what's happening in the network versus what's happening in the page. Quickly help you sort of focus on what's exactly where do I need to spend my time here to make this thing faster. Okay, so moving right along into the profilers now. So I don't know, hopefully most of you have run a profiler. Pretty straightforward. The simplest thing to do in Firebug is just hit the profile button, do your thing, and then hit the profile button again, and you'll get a nice report with probably lots of obfuscated function names if you're profiling live code. The nice thing is you can click on those, and it'll take you right into the actual source code you're dealing with. Dealing with profiling results is kind of a separate topic here. Some of the things to consider are the number of calls to a particular function, how much time was spent in each particular function, etc. It's got an API for profiling, which is nice. So you can actually either embed this in your code or potentially invoke it from the Firebug console. So not only can you invoke various profile sessions, you can pass them a named argument if you want to run multiple profiles in parallel, or if you just have, say, a random block of code that you want to time, the console time and console time end will do that for you. So you don't have any explicit functions or things you're looking for. You just want to know how long did it take to execute this loop or this block of code. Okay, so now we're on to IE developer tools. Similar features with Firebug. One interesting additional feature they have here is the, in addition to the flat function view, which is sort of a top-down sort by slowest to fastest, or sort by max call time, or sort by number of calls, you can do the call tree view, which allows you to drill through the entire call stack and sort of see as it's going through there where things are happening when, what might be masking something else, and give you a better view into really what we're dealing with here. Oh, and additionally, and I didn't mention this. Oh, we're going to get at that. Yeah, so it'll also measure native functions if you're wondering, for example, what's faster, concatenating strings or array join. You could measure stuff like that. And additionally, you can export these results. So, for example, you want to collect a bunch of results over time and then plot them on a chart or something like that. It's really easy to do that with the export feature. The Web Inspector Profiler has a lot of overlap with IE developer tools. The flat function view versus the call tree view. They refer to the flat function view as the heavy view. And they've also got they've implemented the console API a la Firebug. And you can actually implement that manually if you want to supplement that for, say, IE. I call that out in the book in one section. So then that way, if you want to have essentially a programmatic way to invoke all your profiling and timing, you can do that. YUI Profiler, Nicholas, the man of the hour himself, has contributed this to the YUI library. This is a really great cross-browser way to profile pretty much anything you might be interested in, whether it's a specific function or method. You want to measure every instance of some object. You can register its constructor. Register constructor typo. That's register object there. Cut and paste error. Yeah. So then you could also, if you had a static object, in this case not Y node, but say Y DOM or some other singleton style object, just register that whole object, and it will instrument every method on that object for profiling. And it gives you a exportable result set as well, in this case JSON format. Additionally, you can profile anonymous functions, which can be a bit of a challenge, although they do require manual instrumentation. Anyway, flew through that, but get back to the fun part of the night, mingling and chatting with your fellow developers and whatnot. But just to summarize, you should really use these tools so that you can get a deep understanding of what's happening. You should know exactly during every life cycle portion of your page, from request up until onload and well into mouse moves and clicks and all that, what's actually happening. Don't wait for that VP to call you on Saturday night wondering why this page is so slow on dial-up at his girlfriend's house, for example. Yeah, and again, these tools can really help you to focus on optimizing correctly. You don't want to waste tons of time twiddling around over here, let me try this, or let me try that. Really need to optimize the optimization here. Dive right into where the bottlenecks are and strategically speed things up. Thanks for coming out. If you guys want to grab me and talk about tools or YUI or whatever, feel free. If you want to hit me up after the fact, on Twitter, don't really tweet very much, but you can always hit me on email. And of course, we've got the YUI library website where we interact with the community. So I guess I will just shut her down here and keep it moving. Who wants a book?